number 1. So to solve this equation, first thing I'm going to do is rewrite it to give myself some space to work. 3x plus 25 over x plus 7 minus 5, which I'm going to turn into the fraction 5 over 1, equals 3 over x. Essentially what I'm going to do is to multiply the entire equation in order to eliminate my denominators. So I'm going to take the entire equation and I'm going to multiply it by x and by x plus 7. When I distribute, the x plus 7 is going to multiply the numerator. But then I'm dividing by x plus 7. So that step essentially cancels, leaving the x to multiply the 3x plus 25. Distribute. Well, my denominator is just a 1. That's not going to cancel any of my multiplication. So the 5 is going to multiply the x and the x plus 7. The x terms should cancel. So 3 is going to multiply the x plus 7. Simplify my equation. 3x squared plus 25x minus 5x squared minus 35x, 3x plus 21. So at this point, as I recognize that I have some squared terms, I know I have a quadratic. I'm going to try to get this set equal to 0. 3x squared minus 5x squared is negative 2x squared. 25x minus 35x, negative 10x. One step at a time. When possible, I would prefer to have a positive lead coefficient. So I'm actually going to move my x squared term to the other side of the equation by adding 2x squared. At the same time, I'll add 10x. 0 equals 2x squared, 3x plus 10x is 13x plus 21. So I have several options now with this quadratic. I can attempt to factor the quadratic, I can use completing the square, or I can use the quadratic equation to solve. I like to start attempting to factor it. 2x squared plus 13x plus 21 equals 0. 2x squared is not an ideal starting point, but at least the value 2 is a prime value. I know my options are going to be a 2x times an x. 21 has factors of 1 and 21, 3 and 7. 2 times 3 is 6. 7 times 1 is 7. I think if I put a 3 here and a 7 here, they multiply to be positive, they combine to be positive. Both positive, that should check. 2x times 3 would be 6x. 7 times x is 7x. That would combine to be 13x. Let's now set each of these factors equal to 0. and solve. One solution, I have x equal to negative 7 halves. And x equals negative 3. Real quick, I'm going to look at my original equation. In my original equation, I had a denominator of x plus 7. The only value that would make that undefined is if x were equal to negative 7. I also have a denominator of x. A value that would make that undefined is if x was 0. I know that I would not be allowed to include solutions of negative 7 or 0. Neither of my solutions were negative 7 or 0. Negative 7 halves and negative 3 are my solutions.